Good afternoon and welcome to this webinar presented by Selector Software, AI ML Driven Network Operations, the Lumen Success Story. My name is Thomas LaRock and I am a Principal Developer Evangelist here at Selector Software. And with me is Denny Petrie from Lumen. Say hello, Denny.
Hello, everybody.
And tell us a little bit about your role there at Lumen right now.
Yeah, so for the last 5 or 7 years at Lumen, I've been in the infrastructure health group, and my main role within that is to do data analytics. So it's our real focus is on how can we take AI ML type capabilities and solve problems within not just the operations organization. I happen to sit within service assurance, but we do work for both our architecture, our planning, engineering groups, field groups. So we're kind of a one-stop shop if folks want help solving a problem.
And so I love hearing that you're into data. I am a data professional. I've been doing data and databases for a couple decades now. I'm old. I mean, I'm experienced. So the idea of you working with it and being responsible for data analytics, I love it. So now, if I read this right, I believe you've been with Lumen for a while. Do I have it right? 35 years?
You have that absolutely right. I've been there 35 years, and it's I like the way you say I am tenured or so, not old.
Right.
So I'll have to remember that one. That's a great one. Yeah, so I mean, I'll give you a little bit of history. In those 35 years, it's been a great ride. I mean, for someone who's into technology, it's a great industry to be in. It's been fantastic. I started out as a analog switch engineer. You'll kind of see how things changed over the time. So my first job was doing additions and replacements of analog switches. You went to digital voice, and eventually, voice over the top with VoIP. Helped. In probably the late 90s, we were deploying state-of-the-art digital subscriber line to get customers 8 meg service to their house. If you were close enough, if you were sitting next to our central office, you could get 8 meg service, and did that deployments for a few years, moved on to fiber to the curb. Our first fiber to the curb deployment, we offered a whopping 1.5 meg service out of that device. And then went to fiber to the prem. So I was part of an architecture group at the time, and chose that any new growth would be fiber to the prem. And where that capability is now is just amazing. I mean, I have 1 gig service, in my house, could get multi-gig. I know Lumen provides 10 gig service for somebody that kind of needs that kind of bandwidth. So it's amazing how the technology changed. And I would say it's been interesting. And I've kind of seen this transition where early on, the technology was really focused kind of on the hardware side. The hardware kept getting better, and that's how we grew that way. But now, for the last probably 10, 15 years, it's really been the hardware's still changing, but the technology change is really on the software side. You think about we now have virtual routers. We don't have to have hardware-based routers and things like that. And with that has come a whole new challenge in how we manage the networks, right? The devices got smarter, they got chattier, right? You think about a router or an optical device out there, and the amount of compute power it has, it will tell us all kinds of things about that device. So the amount of data that we get from the network has changed drastically. There wasn't much you could do with an analog switch, right? It either worked or it didn't work, and I couldn't interact with it. I couldn't ask it questions. I couldn't do those things. So it's really been a change, from a hardware to a software, and I think that's what's enabled things like I do now on the data analytics side, is taking all that noise that's coming at us from the network and making sense of it and making it actionable for somebody.
So. I hadn't really thought about how, say, in the early 90s, before the internet really took off, before AOL allowed everybody 730 free hours a month, and you were pushing those 8 megs to them, right?
Yeah.
I hadn't really thought about how there was like an absence of data. Like you said, it's analog. It's either working or not. And to me, that's like, oh my God, that I can just imagine the overhead of all the service calls trying to figure out what's really going on. A lot of, let's just say, in my old Six Sigma days, a lot of loopbacks, a lot of rework, and just due to the nature of the tech at the time. And then, of course, I think about mid-90s, things must have really changed for you, because now everybody is online. and now you got to offer this, say, continuous service, and maybe the bandwidth isn't there. Like you said, if you said DSL, I haven't heard that in forever. If you live near where that line was, you got 8 megs. That's so funny to me. So the challenge,
I spent probably a third of my career in the planning organization and doing architecture, so I got to see that from the front end. And as that technology was coming available, we got to deploy it. But from a planning perspective, our capacity was doubling every year, so you had to manage that and you had to build to that. So I mean, it was a challenging time to keep up. And you go from a 2400 baud dial-up modem to there's probably 100 connected devices in my house today that are all just pushing data out there all the time.
Yeah, I see that too when I look at my router settings, my Amplify, and I see it. All the things. I'm like, who is this? Who are these people? People join my guest network, and they're still there. Their footprint is there, and I'm like, oh, it's just you never know, right? It's like I have no idea. So I just reboot it like once a day. That seems to be what to do to fix that. So the challenges you've had through your 35 years, they've certainly changed over time, but has there any that have been, say, common over time? For example, root cause analysis. Is that easier or harder these days? Has that always been a challenge? Is it no longer a challenge?
It's always been a challenge. How we deal with that challenge is different, right? I mean, when you didn't get a lot of information, it took people to go solve those problems. Now with tools like Selector AI and where we can deal with mass amounts of data, near real time, it helps us get to that root cause analysis. And I can give you some examples of things that kind of happen today. And this goes back to when we did a proof of concept with Selector probably a couple of years ago now. One segment of our network has 100 probes distributed across North America. Those probes pretty much continuously talk to the other 99 probes and provide us performance statistics on latency, packet loss, those kind of things. Yeah. That's a tremendous amount of data. There's not enough people that could be looking through that and figuring that what's going on there. And if you take one of our fiber-seeking backhoes in the Midwest here that digs up one of our fibers, that board will light up with alarms on, because you're just impacting a lot of stuff. So with the proof of concept we did, we took all that data and said, okay, let's look at whenever there's an issue in a network, the board lights up, problems everywhere, latency went up everywhere because everything rerouted, right? I mean, we built a protected network so the traffic will reroute, but that does change our performance parameters, specifically latency. So what we do, and if you have an engineer go look at this manually, they'll start to look at past. The problem is where the traffic is now is not what caused the problem.
Right.
So, this was one of the unique things we did with you all was let's go look at what the traffic looked like 15 minutes or 30 minutes before we had the event and map out that to and from location for all, 100 of those probes to all other 100 probes or 99 probes. And then start look what's common. So this is, things that we would not have been able to do in the past without the compute power that's at our fingertips today. So now, we have an event like that. It'll look through the 100 by 100 matrix and say, here is the most common route prior to the event. Go look there first. And we did some simulations on this. It would take a person minimum of 2 hours to go through and do that level of correlation, where now it happens in minutes. So it's one of those things that we've been able to find a lot of chronic type issues by logging this kind of data, because the issue may come in if it's a dirty fiber or if someone bumps a fiber, there's a kink in it or something like that. Those problems can come and go. So this has now over time we get to find those, because by the time a person would go find it, it's a no trouble found, right? Because there's no issues at the time. So I think that's a good example of kind of what we can do today that we would not have been able to back in the analog days or early days of even DSL.
Yeah. So, I mean, but it also sounds, you mentioned a lot of the alerts getting fired. So alert fatigue is probably an issue, very common one today, right? Of course, you also just mentioned troubleshooting, things that are possible for you to speed things up today, but was probably an issue for a long period of time. And of course, I think we're always still behind on things like network automation. You mentioned one other thing, though, is just the volume of data.
Mhm.
There's just more and more infrastructure data being collected, and it's kind of too much for humans to analyze at this point, because it's hard to know what you're supposed to be looking for. All right. It just gets harder and harder. Like if you already know what you're looking for, okay, maybe you can write a query or you have a dashboard for that, but it's the unknown. And that's where I think you want to rely on algorithms more and more, which we'll talk about a little bit. So, okay, so we know the challenges, we know your wonderful history, but let's talk about what you're doing today. What are the business outcomes that you need? And the reason I ask is because I always say, whenever you're going to start something, like you want to have a monitoring solution, whether you build your own or buy one, you want to start with the business outcome first, and then think about how you're going to build the solution to meet that outcome. So what are some of the outcomes that Lumen has that a company like Selector has to come in and help deliver?
Yeah, so our three things. If you think we have, there's really six pillars kind of we think about from a service assurance side. Is don't let it break, right? So if I can, be proactive or predictive enough that it doesn't break, then that's great. If it does break, fix it fast, right? And so you can see how a tool like Selector can help in both of those areas. And then talk to our customers or communicate. Which, believe it or not, we even have some machine learning capabilities that help us communicate with customers. So all three of those things, analytics plays a part in, and tools like Selector have really helped get us to where those where we need to be. So I don't know if there's some area you want to start in first there, but I can probably provide examples in any one of those three. Don't let it break.
I like the don't let it break, but let's say it breaks, and then you said fix it fast. Talk about the SLAs. Talk about like how fast do you have to have something fixed and turn around?
Yeah, it depends. I said, depending on what the customer is, there's different levels of
Yeah.
SLAs that we have, whether it's a residential customer or one of our top enterprise customers or government service. And for things like, we do provide things like next generation 911. We have to make notifications to them within 15 minutes.
Right.
So there's not a lot of human time available if you're going to notify someone in 15 minutes.
Right.
So those are things where we have built machine learning type things to go look for anomalies within that network and then do auto notification of the customers. But some of the more exciting ones, we definitely want to be proactive or react quickly. If I think about on the predictive side, we do have models where we can predict a minimum of hours ahead of time when we're going to have a fault in the network. So those are fantastic when it's not, we never want to have an issue, but if we do, we at least want to be able to plan for it, notify people we're going to have a network event, and then take those actions. So automation comes. You mentioned that's another key. So if we know a card's going to fail, we go ahead and kick it off to our automation platform. It'll order cards. It'll open up a change request for us, and it'll get a technician on site. So in the next appropriate maintenance window, we'll make that change. So is this almost anything you talk about? You can talk about how you analyze the data in that. So I purposely said the next appropriate maintenance window. Maintenance windows aren't just midnight to 5 a.m. anymore. So we actually have tools that go out and look at traffic on the network and determine when the least amount of traffic for over that time of day or day a week and that period. And that's when we'll do the maintenance in that window versus just, hey, we do our maintenance between midnight and 5 a.m. Because it's changed, right? If you're a data center customer, it's a very different model.
That is fascinating. I had never thought about. So in my world of data and applications, like we usually default to off business hours.
Mm-hmm.
I think I've never thought of it this way before, but now I realize what a luxury. Because telecommunications, there is no necessarily off business hour. You have to go find it, right? You have to find that time of day when, like, maybe I can do some maintenance on this particular line. That's amazing. And I think it's great when you highlight the challenges there, because like I was saying, that even that example for 15-minute window for 911. So there's the business objective. Like this is the SLA you have. This is what you have to meet. And then that's why you want to work backwards from there, as opposed to if you're just working on the network operations team thinking, I just need to collect all the data. Just give me all the data I can. So that way, if somebody asks me if something's wrong, I can at least have an idea of what it might be. Well, no, you want to focus in on what the problem and the objective is and then work backwards, because then you build a better solution.
Yeah.
So let me ask you a question about, because you mentioned AI ML plenty of times here. Was there a period of time where if you talked AI ML or bringing in machine learning or anything like that into Lumen, was there any resistance? And if so, how did you overcome the challenge?
Interesting. No, I would say we've never had a resistance because we never told people, right? we didn't come with a solution looking for a problem.
Okay.
We said, you give us a problem, we'll find a solution. Because we didn't want to get wrapped up, and we did that purposely, right? We didn't want to get wrapped up in the buzzwords of, oh, it's machine learning, so it's going to solve everything. Because people think of it as like a magic 8-ball. You just throw a bunch of data in there, you shake it up, and it gives you the answer. It's not the case. I mean, it's I would say it's a lot of supervised machine learning. So it's I never wanted people to think just, oh, here's the data, go. It'll just tell you what the problem is. You just ask it a question. It's not going to happen that way. So it's a lot of work, and not every solution needs an ML, or not every problem needs an ML solution, right? I had someone ask me like, hey, I want to go use your machine learning tools and go find packet loss in the network. I'm like, well, how much packet loss is bad? Well, any. Okay, well, I don't need machine learning to tell me a number is greater than 0, right? Just look at the raw data and it'll tell you that. But there are things where anomaly detection and things like that have absolutely been a benefit for us. You talk about the amount of data. I'll just throw out a stat and kind of let this sink in. Our fault management system processes between 60 and 200,000 transactions every minute, 24 hours a day.
That's not bad.
Yeah, I mean, there's no amount of people you're going to have on staff figuring out what's going on in that mess, right?
Yeah. This is where I tell people when we talk about AI. First of all, a problem with AI, like you said, the terminology. When some people hear AI, they think Skynet. Other people think it's just a block of code. It's just an algorithm. So it's hard to get through those buzzwords sometimes to get people to understand it's just code.
Yeah.
And it's using advanced analytics is what I would say. These are, a regression algorithm has been around for a long time, and it's just doing some simple math, looking to make a prediction and allow that to help you be more efficient in your role. So I do have a question about, like, you said there was no friction, like you were able to do it because you brought it in. You said, we'll solve the problem for you, which I think is great, because you should, again, be focused on the business outcome. Here's what you need, and here's how we can do that. I love that approach. But what about data governance? Any friction with the data governance team there in any way? Anything like that?
Only if you ask them, right?
Only if you ask them.
No, and this is not. No, we have a great relationship with our data people, but the reality is finding data is probably the hardest thing to do when you're trying to solve a problem, right? It's like, where's the data I need to do this? I mean, we have hundreds of databases out there with numerous tables in each of those, and they're all in different languages and those sort of things. So getting access to the data is hard and very time consuming. But one of the things that we also do within my team is, when we get access to the data, we don't ask them to change it. We take it as is. If there's anything we want to do with that data to enhance it or do that, we do it on our side. We don't ask that they do it on that side. So we will always deal with just the raw data and piece it together, from that. So it helps. That way we're not asking people to make changes. It's more efficient if we know what we're looking for. And a lot of our models, when you think about how we made the transition to where we are now, we don't get our requirements and hand those off to somebody else and have them do it. We just do it ourselves to kind of maximize that efficiency with misunderstanding. Like, oh no, here's really what I wanted. Now can you go get that to me? If I just get the raw data, and I think everybody would acknowledge that's dealt with data. You always have where it's not perfect. But we've also kind of set that expectation and say, it's better than nothing. So if I can get you an answer 80% of the time versus none of the time, I'm going to go with 80% of the time. And if I'm, false positives here and there, the benefit I provided the majority of the time offsets that once in a while when it's wrong. And as the data gets better, our solutions get better.
So you touched upon it earlier about how, in terms of troubleshooting, root cause analysis, the AI ML has been a benefit. But talk a little bit more about that. How really has AI ML and these algorithms? How has this impacted the speed and accuracy of identifying and resolving network issues?
Yeah, yeah. And I'll maybe give you an example how we started out probably 5 or 6 years ago
Okay.
with our probably one of our first ML use cases. Uh, we said, hey, we know customers call us for trouble. Why don't we look at that data and anytime there's an abnormal number of customer contacts into us, whether it be chat or calls, let's trigger that as an anomaly and then have someone go look at it. So it was kind of I think we termed it customer as an alarm, right? We had a whole bunch of network alarms. Now we're going to use the customer as an alarm because there's clearly things in the network that customers may find before the network knows it's an issue. And hopefully I'll remember to talk about one of those examples. So we started off with that and say, okay, normally in this 15-minute block, 3 customers call us. All of a sudden, 50 customers call us. There's clearly a problem. So we would send a knock and they would go troubleshoot that. Well, then, we started getting a little better and say, hey, why are we waiting for customers to call us? We know every customer that's on the network and whether they're authenticated or not. Just like you say, you reboot your router every day. Well, if you're on our network, we know you lost authentication there for a period of time. So we started looking at that because now we don't have to rely on the customer. We can just say, hey, okay, this group of customers all of a sudden aren't authenticated anymore. So that's when we trigger off an additional automation and say, okay, we know there's 50 customers that dropped authentication at the same time. Are they on the same cable, route? So we'll actually look at their outside plant facilities and say, oh no, these are not all on this same 25 pair cable, but we actually identify a lot of cable issues because of that. So if we identify it's a cable issue, we'll route that off to the field team to go look at the cable and proactively start to correct that. Now we'll also look, are they all on the same, DSL port? Are they on the same DSL card and router card? And we will find the most common denominator in that group of customers that lost authentication to go, figure out where they were. And also then we take and we put that information onto our IVR. So if any one of those customers call in, because we know their phone numbers, we put it on there. If they call in, we let them know automatically, hey, we know your service is out. We're working on it. That alone has, when you look at the size and scale of our network, that has saved us tens of thousands of dollars in having, an agent answer a call or, just by proactively letting them know that. So we just started out years ago doing something very simple, and it has grown into it's a embedded process within our operations teams today and our field agents and repair centers.
And you touched upon the alerts, right? So you're getting one alert, a bunch of alerts, really. So how have you incorporated AI ML to, say, reduce the number of alerts you would have had with traditional monitoring?
It's interesting because we don't really reduce alerts, right? They're still there. They're going to come in. I can't stop a backhoe from digging up the cable, and I can't do that. It's really how we react to them and how quickly we react so that we get the people to the right place first. Because I'm never going to eliminate alarms, right? In fact, they're probably going to continue to grow as devices get chattier and chattier. It's really being able to pinpoint what do I want to go fix, and can I tie the automation to go fix that so it doesn't take a person and it happens very quickly.
Oh, you mentioned automation. So are you currently using a lot of AI ML for any sort of automation strategies?
Yeah, so we have an orchestration platform that handles a lot of our automation. So anything that we do, well, a couple things. We want any of our technicians a single pane of glass. So I don't want them looking at a bunch of different dashboards on a different systems. So anytime we build, or find an anomaly that we want to alert on, if it's something we want the NOC to do, we send it into our fault management system, and it becomes a ticket and alert for them, just like any alarm from the network. The same thing, we have also linked our analytics tools to our automation tools. So if we identify there is errors on one member of a lag group, we'll kick that off to our automation platform. It will go out and look and say, yep, there's errors on that link. Yep, there's plenty of capacity. Go take that link out of service and then notify, the NOC to put that on their list to have someone go look at it. So all that will happen automatically without having to have human intervention to take a bad member out of a lag group.
So I think you've hinted at this a couple of times with some examples, but it sounds to me like you're doing quite a bit of, say, predictions, predictive maintenance, predictive outage type thing. So can you talk about how you're leveraging AI ML for something where you're being a little more preventative, and has it reduced downtime?
Yeah, so I'll give you the one example with one vendor we work really close with. To look, we found a signature said within at least within 2 hours prior to the card failing, we actually know that it's going to fail with a high enough level of probability that the vendor said, yeah, if you tell us it's going to fail, we're going to ship you a card. So I think I mentioned that earlier, but we'll go ahead and ship. Our automation will go and order a card, have it shipped to the site, do the change request, get a technician on site and do that. An outage would take, unplanned outage would take probably 2 to 3 hours to resolve that if we just let it fail on its own. But by being able to predict that and proactively going after it, we reduce that time to minutes, right? Everything's ready to go. We pull a card, plug the card. So you've got probably a few minutes worth of outage compared to a planned event as opposed to hours of an unplanned event. And that's one of the things we're growing. Those are hard to come by, honestly, though. It's to find that right signature where you, with enough probability that you've identified the true problem, as opposed to generating a lot of false positives, where now you're creating work for a group that's already busy. Those are hard to find. I think we'll get better at it as the tools improve, and the data. As you get more and more data, it just helps improve those things.
Oh, you say more data, and we touched upon that earlier about how the amount of telemetry data, it just grows. It's never less with each passing year. I always ask that question in my sessions: who here is managing less data today than they were a year ago? And nobody ever raises their hand. But it's beyond the ability of one person or even the team of people to really analyze in real time, for sure, no question. So, what were some of the techniques that you adopted, say, first, AI ML techniques, in order to help overcome that just wave of data that you're drowning in?
Yeah, probably the most powerful for us was just straight out anomaly detection. Some of the early cases we didn't even look for what was in the data. We just looked for how much data was it. One of the problems we found was, a device would typically send us 1 million messages a day. We will look at it by type of device. We found one device in there was sending us 80 million messages a day, as opposed to every other thing was 1 million. So it's like, all right, let's just go look at that. Why is it talking to us so much? Because I do believe that anytime the machines are telling us something, they're telling us for a reason.
Yeah.
We just don't always know that reason or understand that reason up front. So it's worth going and looking at. So in that case, we went and looked, and there was a card on that device that was failing and resetting so fast, our alarm systems weren't catching it, because it was every time they would kind of look, it's like, oh, it's cleared. So just millions of messages coming in on a regular basis that it was absolutely impacting customer service because the card was just rebooting.
Yeah.
So it's anomaly detection to me is where you start, and don't even always look at what's in the data, just look at the quantity of data.
And is there a specific technique for that, or is that just straight up just querying your data, saying, show me one, like that's just doing a standard group by, so to speak?
Yeah, in that case, it was just we were already storing that data because it was syslog data, so we keep that for other things. It was just looking at the logs and saying, what's going on here? I mean, how much is each of us sending us? So it was just a straight discount, right? How many come in every week? So
did you then transition to using some sort of regression model?
No, because one of the things is our team doesn't. We don't necessarily worry about what all the different models are, like random forest and all those things. We rely on tools like you all and other analytics tools we have with what they have built into them. Okay. So we want to feed it the data and say, you kind of look and tell us what the best model is for this.
Okay.
And the other thing is we like to apply the human piece to this too, because I'll give you an example. You can have a poorly performing circuit that's very consistent. doesn't mean it's bad, right? Straight out anomaly detection will never find that because it's consistently poor. So we've learned to take another step and add some human side to that and say, okay, we know a circuit from Kansas City to St. Louis. We know what the distance is between those two. We know what theoretically we know how fast light travels. We add it through a few milliseconds of latency on either end of that, and that circuit should be in this range. And I forget, I think it takes 32 milliseconds to go across the country or something like that. So we're going from New York to LA and we see a circuit that's at 70 milliseconds. It's always at 70 milliseconds. It's still bad. Yeah. So we want to go look at it. So we put additional guidelines around even what the machines and anomaly detection will tell us based on what we know.
Yeah, I've had to do that. I've had to explain to somebody the speed of light.
Yeah.
When they were complaining about the data not arriving fast enough at 800 miles away. And I started doing the math and the volume of data involved. And I'm like, honestly, physics says the minimum amount of time is this.
Yeah. So then you'll appreciate this too. Then you can throw in the Halvorsign formula, which calculates distance based on the curvature of the Earth.
So, okay. Yeah. I didn't get that complex. Once they got that email, they'd heard enough, I think. They didn't want to hear anything else. So let's talk about how your environment changes. It grows, it adapts, new things come on, new devices, new issues, network patterns develop. Have you found the use of AI ML has allowed, say, that it can adapt without a lot of manual intervention on your behalf?
I'm going to say not yet. Because I think, and maybe it's because so much of ours is supervised machine learning, where we kind of know what we're going to go. We know what problem we're trying to solve typically, so we're going that direction. Can it get there? Yeah, I mean, we're doing a lot of trials with generative AI, and I think it's going to continue to improve. I mean, but I don't believe it's there yet. I don't think it's like I said earlier, it's not the magic 8-ball. I can't just throw data in it comes back with the right answers for me at this time. I think it will get there. I mean, if you had asked me 2 years ago, would I ever order up a driverless taxi and hop in a car with no driver? I'd have said, nah, probably not. But a couple months ago, I did that. So out in Phoenix with the Waymo.
Right.
So
I think the important thing to mention there is that data without context is useless. So if suddenly your network grows, you acquire a new company, they have all these new devices or issues specific for their company, you're not really going to know necessarily what to do with that data unless you provide the context for it. Like somebody has to enrich the metadata that's being brought in there so you can make sense of it all. Kind of like what you're saying with generative AI. Speaking of which, are you using the new Selector Copilot? Is that something you're doing at Lumen yet?
Not yet. We are using the Microsoft Copilot platform, which is part of our, all of our Microsoft suites. We are testing it there. It is absolutely confined to within the Lumen assets, so no data that we put in there can leave, because there are a lot of security concerns with that. But we have found it to be extremely useful. You can reply to emails, and actually some of our engineers who do a lot of coding will say that having the Copilot with GitHub and GitLab and doing Python coding probably saves them 40% of their time. So yeah, I'm looking forward to using that in Selector because if it proves out like everything else, it'll be an extremely viable thing and time savings for us. But I always caution the engineers, like, don't just take it for granted that it's right.
Yeah.
To make sure it's still doing what you want it to do and prove it is. But for things like commenting out code and stuff, it's been fantastic at that.
The GitHub Copilot I find just amazing. Yeah. And it's a significant time saver. So here's how I liken it is that I can ask questions of a chatbot, which is essentially asking questions of my data, right? Asking questions of data is better than me having to go through dashboards of data. Mm-hmm. But with generative AI, with a thing like Selector Copilot, now you have the ability to have a conversation with your data. And that is a significant time saver. I'm not sure a lot of people have truly started to understand. I think they will. I mean, ChatGPT has been out for just a year. Not everybody's used it. They've heard of it. They don't know. They hear it, writes weird stories and has feelings. But the thing is, once they start seeing it in action, once they start using it as for GitHub Copilot, once you start understanding how to interact with it, it just becomes another tool in your toolbox.
Well, let me change my answer, because if what you're talking about, maybe I just don't understand the branding of the Copilot with Selector AI. If it's the interaction with Teams and me and I'll ask questions through Teams and pull data that way through the natural language processing, yes, we absolutely use that.
Oh yeah, we have.
And that is valuable. Okay.
No, we have generative AI, but I wasn't sure if Copilot had rolled out to Lumen yet. So basically, we have an updated version of it that you should look into.
Okay.
So you had mentioned this before about getting started with anomaly detection. So if somebody's watching this webinar and they're on the fence, so like I'm still fearful of AI, ML, and automation and these things, what's a thing that you would tell them to get started with? Just anomaly detection in general?
Yeah, anomaly detection is by far, I think, the easiest and has proven to be the most consistent value over time for almost anything we look at. Or you even think about, we want to get for simple things. So start simple. So, I mean, get small wins. Don't start out trying to do some very complex AI ML thing. Do something simple. Just like I said, look at the number of events or something coming from a particular network, and then go look at it. Because when you can show the value, and I was like, when I went to NOC and say, hey, can you guys go look at this device? And they said, oh yeah, there's something wrong with it. Then I start to build credibility, right? If I go ask them to look at a whole bunch of stuff that's wrong, then they're not going to ask me anymore, right? So just go do something simple. Doesn't matter what it is. Customer, how many customer alarms are coming at us was a very simple thing to start to look at, and then grow from there as you get to successes. Because when you get to successes, it just builds momentum, and then people will start to ask you for solutions. And I know I mentioned it earlier, but I'd say that again. Don't just assume that ML is the solution to the answer. That's what we don't want people to come and tell us how to solve the problem. You give us a problem, we'll work with you to solve it, but let us use the variety of tools that we have at our fingertips to help you solve that in the most efficient way and the best answer possible.
I love the answer about anomaly detection, because it brings me back to something I had done a long time ago, which was for database backups. I wanted to know, or actually it was database jobs. Some of them were backups, but I wanted to know if the job was running long. And traditional monitoring platform would say, if your job runs longer than 120 seconds, I'll send you an alert. Well, all my backups took way longer than 2 minutes. So every night I was just getting tons of alerts going, this is useless. So I finally realized, oh, well, I'm a math guy. I can calculate a mean, a standard deviation, and last 90 days worth of data. And I could just say, so if a job is running right now and is more than 2 standard deviations away, that's an outlier. Now send me that alert. And that's how I got started on this path too, through anomaly detection. And that simple thing, mean and standard deviation, that's actually technically advanced analytics. This is statistical work at play, right? Statistical analysis. So advanced analytics, anything you can do, if you can visualize the data, box plot, looking for an outlier, things like that. I always say, get started with that to begin with. And of course, then when you start dealing and understanding with the volume of data, whatever, you might need to look to an actual platform to help you make sense of it all. Mm-hmm. But at least you'll get the basis of the understanding. So when you do start to think about a platform, you'll know what you're looking at. You'll know how we've arrived at those answers as well. So looking forward, anything on the horizon, innovations, advancements, MI, ML that you might be excited about, say, for the future of network operations?
I think going forward, we use kind of AI ML as a offboard platform. I hope we start to get that built into some of the equipment and features and that as it rolls out, so it just becomes inherent in those devices. They start to get more intelligent, and maybe that's where we can start to slow down the volume of data coming to us. If they get more intelligent, and rather than send us 10,000 minor alarms, give us one alarm with a good indication. And that's one of the things we talk to our vendors about is getting more intelligence within their devices, their platforms, so that they can, because really every minor alarm is a predictive, it's a prediction that something's going to happen.
Right.
So we would like them to get more intelligent to tell us what's going to happen, and let's go that way versus us having to figure out on our end and go back to you. So I think you're going to see that as things progress. I don't know how quick that'll be. I think back in 30 years ago, I took working on a computer science degree. I took an AI class back 30 years ago. Who knew it was going to take 25 more years before we actually start to apply some of that stuff into the field I chose. So, but yeah, no, I think things are certainly accelerating quicker. So I do think there's a lot to come, and looking forward to all the things that we can do with that.
Same here. I would also put quantum computing on the radar as well. The ability to speed up operations on top of everything, all the other advances that are coming. So I'm kind of excited about that. All right, last question before we wrap up. How do you keep yourself and your team updated with all of the latest trends going on, the network operations, AI, ML? What are some sources or resources that you and your team at Lumen rely on?
Yeah, so it's a lot of this is about the people, right? I would say anybody that's looking to create groups or do this, make sure you get the right people, because the right people have the right attitude. Our teams are perpetually curious. So all I got to do is kind of ask a question. They'll go figure it out, right? Because they don't like not knowing the answer. So I think reading a lot, consuming whatever you can, ask a lot of questions. That's how you learn. That it just so happens that, I don't know if you'll be able to see this, but I think there's a book.
It's blurred out.
Yeah, it's blurred out.
Put it in front of your face.
Yeah. Yeah, not going to come through, but there's a book that one of your colleagues has written about machine learning. So, I think it's a great. It starts from a beginner level and gets to pretty advanced stuff. So it's one of the things I'm working my way through. So I read and ask questions, and be surround yourself with people that are curious, because together you'll go find the answers.
All right, I think we're at time. Denny, I really thank you for your time today. This was great. We should do this again.
Yeah, absolutely. Yeah, and it's all an interesting conversation. So thanks for the invite.
And for more information about our platform and how we use AI ML to solve problems for our customers, including Lumen, head over to selector.ai. And on behalf of Denny and myself, Thomas LaRock, I thank you for attending, and I look forward to seeing you again on a future webinar.